Hello! Today we will show you how to place 3D objects with dynamics in a video. First, render the video as an image sequence using video editing or animation software such as Premiere Pro, Vegas Pro, or After Effects. You can also use an online converter. Then open the Cinema 4D and set the project frame rate to match that of your image sequence. In our case, it is 30 frames per second. Now create a Redshift standard camera by opening the Redshift menu, selecting Cameras, and clicking on the standard. To load a background image sequence, click on the RS camera in the Object Manager, select the Background tab, go to the Background property and press Override button, go to the Image property, load the first image of the image sequence, click on the small triangle to the right of the image, go to the Animation tab, set the Mode property to Simple, set the frame rate to match the frame rate of your project, in our case it is 30, press the Detect Frames button, after which the start and end frames will be set. Here it is 0 and 120. Extend the timeline to 120 frames, same as end frame. Enter the camera by clicking on the square icon to the right of the camera object in the Object Manager, and click on the Play Forwards button to test the animation. The video may be slow when you first play it, but the speed will increase from the second play. We see smoke moving and grass swaying. Now the video plays fine. Stop the animation and go to the start of the timeline. Now let's calibrate the camera. To more clearly see the grid, lines and pin that we will create during calibration, reduce the exposure in the Background tab of the RS camera to -3. Since the video was shot by a camera on a stationary tripod, we can calibrate the camera using any image from the sequence. Let it be the first image. Right-click on the RS camera in the Object Manager, select Tracker Text, and click Camera Calibrator. The Camera Calibrator expression has appeared to the right of the RS camera object in the Object Manager. Click on the Camera Calibrator expression and select Calibrate tab. Choose for yourself the directions of the coordinate axis. Let the X and Z axis run along the sides of the fence, and the Y axis run vertically along the pole. Press the Add Grid button and place the grid that appears on a rectangular surface in YZ plane by dragging the corners of the grid. Then press the Shift key and click on one of the horizontal sides of the grid, after which this side as well as the horizontal planes parallel to it will turn red. It indicates that these lines have become parallel to the X-axis. But this is not what we need. We need the horizontal lines to be parallel to the Z-axis. Therefore, while holding the Shift key, click on the horizontal side of the grid again, after which the horizontal lines of the grid will turn green. It indicates that these lines have become parallel to the Y-axis. This is also not what we need. Therefore, while holding the Shift key, click on the horizontal side of the grid again one more time. The horizontal lines of the grid will turn blue. It indicates that these lines have become parallel to Z-axis. This is what we need. Next, press the Shift key and click on one of the vertical sides of the grid until that side, as well as the vertical lines parallel to it, turn green. It indicates that these lines have become parallel to the Y-axis. You can create a second grid for the other side of the fence, but to make our example cover more options, we will create lines. Press the Add Lines button and place the line that appears along the top of the other sides of the fence by dragging the ends of the line. Then press the Shift key and click on it once so that it turns red. It indicates that the line has become parallel to the X-axis. Create another line along the bottom of the sides of the fence. and also make it parallel to the x-axis. You can also create a third line along this pole. And make it parallel to the y-axis. Now set the pin. It will be the initial center of the coordinate axis for the objects you will add or create. Add the pin by pressing Add Pin button. A small orange circle has appeared in the center of the viewport. It's a pin. Drag the pin to the corner of the grid, the length of one side of which you know. We will drag it to the bottom of the pole. And enter the known length. In our case, it is the height of the fence, which is 150 centimeters. So select the grid, check the known length Y box, and type 150. In the calibration status of the Calibrate tab, the colors for the camera parameters are green and yellow. This indicates that we have calibrated the camera quite accurately. Click on the RS camera in the Object Manager, go to the Background tab, and return the exposure to 0. Now create a plane. It will coincide with the ground surface. Increase its size and drag it close to the sides of the fence. Switch to the top view in the viewport and position the plane more precisely using the arrow keys on your keyboard. Then return to the perspective view. Create a cylinder, lift it up, and reduce its radius to about 5 centimeters. Press the Ctrl key and drag the cylinder against the z-axis to the nearest pole to create a copy of the cylinder in its place. Then, in the same way, create another copy of the cylinder for the pole located further against the z-axis. Next, create 2 copies of the cylinder along the x-axis. After that, create a cube, lift it up, reduce the size x and y so that they are equal to the width and height of the wooden board. This is about 4 and 15 centimeters. Increase the size z to about 900 centimeters. And align the cube with the bottom bar of the left side of the fence. Switch to the top view in the viewport and position the cube relative to the plane and poles more precisely using the arrow keys on your keyboard. Then return to the perspective view. Press the Ctrl key and drag the cylinder along the y-axis to the middle board to create a copy of the cube in its place. Then, in the same way, create another copy of the cube for the top board of the fence. Create another cube, lift it up, increase the size x to about 900 centimeters, reduce the size y and z so that they are equal to the height and width of the board, 15 and 4 centimeters. And align the cube with the bottom bar of the right side of the fence. Position the cube more precisely in the top view in the viewport. And create copies of it for the middle and top boards of the right side of the fence. Now select all the cylinders and cubes as well as the plane in the Object Manager. Right-click on any of the selected objects, choose Bullet Text, and click on Collider Body to define all selected objects as obstacles. Next, create a sphere. Reduce its radius to 50 centimeters. Lift it up. Go to the Coordinates tab. Change the x and z coordinates so that it becomes closer to us. Right-click on the sphere in the Object Manager. Select Bullet Text and click on the Rigid Body. Select the Dynamics Body expression to the right of the sphere in the Object Manager. Go to the Dynamics tab. Check the Custom Initial Velocity box. Set the initial linear velocity along the x, y, and z axis to -1400, 400, and 1200 centimeters, respectively. Go to the Collision tab and increase the bounce property to 25%. Click on the Play Forwards button to test the animation. Stop the animation and go to the start of the timeline. Open the Material Manager. Create a new Redshift standard material by clicking on the new Default Material Plus logo. Double-click on the Material Preview to open the node editor. Click on the Add Nodes Plus logo. Search for ramp. Drag and drop the ramp into the node editor. Go to the ramp properties. Click on the Load Preset button. Select Full Colors. Connect the Out Color output of the ramp node to color input of the Redshift standard material node. Close the node editor. Apply the material to the sphere. And close the Material Manager. To track the results in real time, run the Redshift Interactive Preview rendering by opening the Redshift menu, clicking on RS Render View, and pressing the Start button. Now let's add lighting and shadow for the sphere. During the video shooting, the sun was on the right at an angle of about 60 degrees. Therefore, the shadow will be to the left of the sphere. Right-click on the plane object in the Object Manager, select Render Text, and click on the RS object. Select the RS object tag to the right of the plane in the Object Manager. Go to the Matte tab. Check Override box. Then check the Enabled box in General section to make the plane transparent. And check the Enabled box in Shadow section so that we can see the shadow. Create a Redshift Physical Sun by opening the Redshift menu, selecting Lights, and clicking on the Physical Sun. Go to the Coordinates tab and adjust the rotation properties so that the shadow falls to the left of the sphere. Go to the Details tab and adjust the shadow properties. Let's add transparency. Set the transparency property to 0.3. Make all cylinders and cubes invisible to the viewport and render by double-clicking on the visibility dots to the right of them while holding down the Alt key. This is what we got after rendering. Thank you for your attention, subscribe to the channel and put your finger up.